Hello guys, how's it going? My name is Rodolfo Moreira. I'm a data specialist in create and building some products using data science, machine learning, artificial intelligence in general. Also here in Brazil, I'm a professor of artificial intelligence and Chatbot. And today I will teaching for you guys, and I will try to made a tutorial here with how we can use the LLM, the large language model, the GPT, the artificial intelligence, and all this stuff will be the hype now. So let's try to do some new training with your own data here to get some part of ChatGPT. You're gonna use the HuggingFace, is a library we can able for you do and try to do some new things. Use the GPT2. You're gonna use that to create a new chatbot. You're gonna help all the students inside my platform. So in Brazil, I will release a new platform right now. It's a platform will have a lot of exclusive content with some tips and some courses, some training to your guys and all the students all over the world to understand more about the data universe, the universe of technology for anyone that can start a new career. So I love to do that, and I will release in Brazil with the Portuguese, and the next month I guess I will release to all of the world using the English. So I'm very excited to get some example to do that. I will try to create a new chatbot with large language model with the backend or the base of your chatbot using the GPT. So also we're going to use the collab research here, then help us with a Jupyter notebook for free, and also help us to use GPU to do the maths and all the calcs about your model here, because when we start to use some training models using the LLM, we have to use the GPU, because the GPU versus the CPU. The CPU is the entire processment about your computers and machines, right? We all understand a little bit about the CPU, but it's good to do the maths and do the optimization about your calculations, but it's not really good to do the parallelize about all the maths, about all these this calculation. So the GPU brings to us the ability to we can parallelize all the maths and all the calculus inside about the tensors and the matrices. They help us to understand more your data. So to work with some LLM and a couple of models of deep learning or some kind of model, we can use a lot of data. We have to use the GPU. So the collab research here, we can use the GPU. So let's beginning made this configuration here in collab research. Outside of the connect, you're gonna click change runtime type. Here you're gonna deliver and stay with the Python 3 you're gonna use here. So for the machine, you're gonna use T4 GPU. So the Google have some limitations to do that, because we not can use the GPU for the whole day long. They not tell for us how will be the limitations, but it's good to do some tests, and to understand how we can train your model using the GPU, right? So it's not be viable to use the entire day the GPU. We have some limitations per day to use. So you're gonna click here in save, and you can connect here. Also, we're gonna start to import your libraries here. So the first library will be the transformers. Transformers is a great library about the HuggingFace. Is a company that do the maintenance and turns available and possible to work with LLM through this library transformers. So we're gonna import here the GPT2 tokenizer. Also the GPT2 LM head model, And last but not least, you're gonna use the optimizer add-on GPU. So first, you're gonna every data set or every text that you use here to inside your model to do the train or to do some predict about the next text, you're gonna use the token. So we have to format the entire whole data set to work as a tokenizer. So this is gonna help for us. So to do the fine tuning, the thing you're gonna use here, or to use to predict, to use some model, to pre-training model to answer some questions here with the help of LLM, you have to do this tokenizer to make the encoding about your data to write configuration that our model is gonna need. So this is one import that we have to do here. And also the LM head model will be bringing for us the model to we do this prediction and to do the training. So we have always in use the scenario about the GPT2 or the LLM. We have to tokenizer and bring the model. So to do the train about your model using your own data, you're gonna use the ADA W. The ADA is optimizer that has been used with a lot of models of machine learning, also the models of the deep learning here. But when I use the W, you're gonna use the gradient descending to do the training, evaluate the aids about your calculation. So we have an optimizer here, more good to do an optimizer here. So you're gonna use the ADW, right? Also, you're gonna use your PyTorch. The torch is gonna help us to data treatment, to do the data set or the data loader understandable for the GPT2 and the way to do this fine tunage. So we're gonna use the torch for that. And also, and I use the machine here with GPU, we need to explain for code for the Python here and all this the base of code. When you will do these calculations in the maths about LLM training here, we have to help your code to understand you're going to use the GPU instead of the CPU, right? So the torch help us to do that. So the PyTorch is a great library to use the deep learning. So the whole low community loves to use the PyTorch. So some kind of community, right? Loves to use the PyTorch. So you're going to use the techniques very similar to train a deep learn, to train your GPT-2 model here. So from Torch, you're gonna get the utils, also data. You're gonna import the dataset and data loader. And also to do the manipulation about your data, you're gonna use the frequently asked questions as your own data set to help your model of the GPT-2 understand more about your personal questions and answers about your platform. So to do that, you're gonna use the simple JSON library to do this data manipulation, right? So we can execute that. Okay, so let's open here your fact data with open. fact.json, and you're gonna click here to upload your file. The fact data that we will use here is just a couple of questions, right? So our main goal here use the GenAI, the artificial intelligence, to generate questions here about all the things, for example, on the universe of data, like what it is data science, what is a data engineer, questions about the field, but one specific question about how I get in touch, what types of curves do you offer, and some questions more specify about our platform that the GPT or another large language model will try answer as a open answer, right? It's not a specified answer. So you're gonna use here your FAQ data to do this kind of training, right? So this is something very important because for any questions, I got a couple of questions here. And for any questions, I try to put 10 examples from questions and answer. This is something that I will call as balance of your data set. This is so much important for your not create a bias in your model when I'm gonna train your model. Because if I have for example, I run the records about questions and answer, and 90% of these records it's about one question, and 10% another is some other questions. When I have that, your model, we're gonna create or generate a bias, and any question that we can answer for your LLM, you're gonna answer if the examples that we have more inside my data. So this is important to do. This is something important when I used to work as a data science and machine learning engineer, artificial intelligence in general. This is something very important about the balance about your data set training, right? So I will leave here in the description of this video the FAQ JSON data here. I will call it this open as F, and I will pass the FAQ data here. You're gonna receive the JSON load F. If everything goes right, I will show her here the FAQ data. So I put an L and plus here. Let me try again. Okay, so right now we already have your data set here. I can delete this line. Right now, let's create a variable called device. This is so important because we're gonna choose what kind of device is available to do the maths and do all the things you have to do to train your model here. Like I said before, you're gonna use the GPU, and to use the GPU, you can the NVIDIA help us with the CUDA framework. Is a framework responsible to make these connections between your data, we're training here using Python, in all the situations to do this large training of data with the GPU. So the CUDA is a framework responsible to do that. And we're gonna create a variable called device. The default value here will be CUDA. So if torch from PyTorch CUDA is available, they're gonna be the pattern, the base value here, CUDA. If not, will be CPU, right? Let's check. So here we can see the CUDA is available because we make this change. So every part of a CUDA, like your data set, like your model, you're gonna need declare for your code that you will use here the CUDA, not the CPU, right? Because also you can try between your tests, all the playground you have here, you can try use just only CPU to compare the results, actually how fast you can train your data and get the new results using just CUDA, right? So this is gonna be a variable that we use here in a couple parts of code, right? So it's very important to do that because we need to put your data set and all the stuff you go get inside a math scenario, calculation scenario for your GPU. Now you need to create the variables you're gonna use here to tokenizer in the model from GPT-2. So you're going to start using the tokenizer. You're going to receive the GPT2 tokenizer from pre-trained. And we have a couple of models here in English to use the GPT-2. The first one could be the GPT-2 alone. Here is the smallest dataset, smallest pre-training model that we have here of large language model using the GPT-2. Also, we have the small. It's biggest to the only just GPT-2, and also the medium and the large model. Here, when we have the small, the medium, and the large, it's just the ordination about how you can have a number of the registers, a number of variables will be used to train this model. So here, using the GPU from Collab Research, we can do your models and make the tests here with the medium training, so we have more, it's bigger than obvious than the small GPT-2 and also the only GPT-2. It's not the biggest model than the large, but can help us to understand more about this LM model, how we're gonna do this training and all the stuff like that to use it here in your code, right? So you're gonna use it here, the GPT-2 medium. Also, I will make a personalizer here. When I use your data on GPT-2 to do this training, is a good practice and also necessary. We declare the tokenizer, the pattern of tokens you're gonna use here from your model, right? So for that, you're gonna use the basic information here about this model from GPT-2 mapping. It's gonna be the tokenizer EOS token. So it's just something more to or called understand how can it be the partner of tokens you're gonna use here. So you can personalize or use the partner from your model pre-training. Sometimes when start to do the training about your model and you not use the tokenizer EOS token here to define the PED token, maybe our code is gonna bring you a lot of warnings here or sometimes some errors because he can define by yourself how this partner of the token you're gonna use. So this is something for the code, right? Also, we're gonna use the model here. The model will be the GPT-2 LM head model. Also, you're gonna get from pre-trained. This is something important if it's your first time using the GPT-2 here. The pre-trained tokenizer and the model, they both can be found in the same path here. So I can use also the GPT-2 medium. All right, so last but not least, you need to identify for code here for your machine. How are gonna be the kind of the processment, right? So you're gonna pass the model to device, and device is gonna be the value of CUDA because it's available here in your machine, right? Actually, I forgot to pass model here, so right now I think it's gonna work. If your first time execute this block of code, you're gonna download all the tokens and all the model here. So right now we already do all these configurations we have here. So let's start the data manipulation for do this training, this fine tuning inside your model, right? So we're gonna need to create a new data set, also a data loader here to help the code understand more the kind of data and tokenizers that we're gonna use here. So let's create a new function called process FAQ data. You're gonna receive the data, the tokenizer, and also the max length. The max length will be responsible to truncate resize of your input text here, because it's important for the model has a defined sizes here, the same size for all the tokenizers, for all their input text. For you do the input, the fine tonnage here. So you're gonna deliver and use the 512. In this case, if my text, my input of text, it's more than 512 length, the data manipulation will be the truncate the data, right? If I have less than 512, my data manipulation here, the torch, will be create some fake data here. And after that, you're gonna make a configuration here for the model understand what the real data you're gonna use, how is the fake data it has need to use us for do this training of the model, right? So let's put all this together, create the first variable, call it processed data here. It's gonna be an array, because this variable is going to be the return about this function. Is a data preparation for your do the tokenizer and do this configuration for the torch, right? So let's do a looping here for fac inside your data. Let me get indenting the code here. So for fac inside the data, it's gonna be a text in this format here. It's gonna be a string with question. A dynamic data inside your fake, call it question. Is the same name of the block of code here from your JSON, right? So we're gonna use the question, the answer here. Also, you're gonna break a line and deliver the answer and get the dynamic data from fac, call it answer2, right? In the end of this string, I'm gonna break a line again. Okay, so let's start to use the encoding. Will be the responsible to tokenizer and to help your data get more flexible for your model here. So encoding, you're gonna receive the tokenizer, and inside the tokenizer, you're gonna deliver the text, return tensors. The tensor model will be the PyTorch here, the PT. Also the max length, I'm going to receive the max length. The truncation that I said before, for get the same length of block of code for any token or any text that we're going to put here. Truncation will be received the true. Truncate is right. It depending the way the model or the tokenizer be responsible to do that, you're going to use the max length. So this is the first part about your encoding here. When I do this process of the encoding your data here, we're gonna use the input IDs. This is IDs for any token that my tokenizer made in here from my text. And also the attention mask. The attention mask, as I said before, if my block of text here, if the text that I will deliver is less from my max length, the tokenizer will be responsible to create new tokens, new fake tokens. So the attention max is gonna make some warning. You're gonna make a heads up here for the model. What is the data, the real data that are delivered with my text, and how are the fake data here. My model just pay attention if the things would really gonna make change here in my model, right? So the attention mask is the form for I'm warning my model what's the real data, yours the fake data between here my max length, right? The input IDs we're gonna receive from encoding, get the input IDs, and also from encoding we're gonna get your attention mask. When I use here, you use the model of the PyTorch for the tensor, they create another dimension for use the batch. It's just like another brackets actually. So you're gonna use the squeeze and remove this dimension because we will not use it here. So I can do the squeeze to remove the first dimension for input IDs and also to attention mask, right? And let's add your data here that we encode your tokenizer right now. Let's append it with the input IDs. You're gonna receive the input IDs, attention mask. You're gonna receive also the attention mask. And last but not least, this is important for the model, we have to send the labels here. So the labels will be the same input IDs, right? Because the IDs is already a label here for your code, right? So we're gonna not need to create some label just for this part of code here. And this is another thing that's really important to use here. Because we use here the GPU, right, to do all the data processment. So it's important for all the data you're gonna use to do this training is the same way, the same location with the data will be the model. So to do that, you're gonna use the two here, input inside the device, the base device or the partner device inside your code. So let's reconnect here because I'm staying a long time to only do the code. I'm gonna put all this code inside my device here, right? Because when I use the train model, I don't have all the data and all the model inside in the same location, in the same way of the processing the data, that will bring it for us an error, informing that the data in the model, it's not the same location to do the training, right? So let me run again here because we'll be needed. My machine need to reconnect here. And also, last but not least, you're gonna use the return here and pass the process data that you do the manipulation here to do the tokenizer of your data for the model. Okay, so let's test your data processing here. So outside my function, so I will create the variable processed fac data. You're gonna receive the function process fac data. You're gonna pass your JSON here, the fac data, and also the tokenizer. Okay, and after that you're gonna put all this data ready to do the training inside my GPT model, inside the another function that we're gonna create here. The training function is gonna need to use the data loader from the PyTorch. So after this data manipulation, this is already ready for you use here to data loader. So you're gonna call it fac loader here, and we will receive the function from PyTorch to do this configuration. You're gonna receive the fake data. You're gonna put two parameters it's necessary about the training here. The batch size will be the 2, and also shuffle if h on start. You're gonna receive the true. So this is two parameters here that we use to do this training. So the batch size is the size about this processment of data. So two of time, and also the shuffle to do the random. It's not the same order that I send my JSON. So we're gonna use the shuffle here to make a random data set. So let me execute here to understand if everything's gonna right. So we have the first problem. So truncate here, it's wrong. It's truncation. Also input IDs, I add an S here. I forgot the IDs. In this list we cannot find the squeeze. I forgot an S because they not find the squeeze. And also I forgot the ID. I'm wrong the entire block of code here. But right now it's work. Also, in the description of this video, I will leave my GitHub, and also all the code we already created here. So it's more easily for you guys do this. It's more easily for you guys compare the code, right? Okay, so right now let's make the function for training your data here. So first you're gonna create the optimizer. The optimizer here will receive the item W, right, to help us to do the gradient descending, to help between the epochs here to do this training inside your model. It will be in the W, and then here is equal optimizer. So Adam, you're gonna receive the model parameters. All these parameters all the way the GPT2 medium here was training, and also you're gonna pass the learning rate. Will be scientific notation here 5 times 10 elevated -5, right? So it's just basic number here on this notation, right? So here's optimizer, okay, and right now you can create your function for train your data. So here you're gonna receive the data loader, the optimizer, the epochs. The epochs will be the looping with your model here you're gonna use to train your data. So for each epoch or model, you're gonna create a training test code. You're gonna understand how will be the loss from this prediction, how we're gonna be good or how gonna go bad in this prediction. We do the back propagation to help your model understand how you can improve the predict. And last but not least, you're gonna save your model, your data and your model here with the new path of learning here that your model has understand right now. So the epochs are gonna use the base value here, part in S3. So the epochs here, we have a lot of situations to understand how we're gonna be the right number of epochs. So it's good not. If you're gonna use to production, we can use a lot of techniques to understand how we're gonna beat the right number of epochs here, because the epochs we're gonna try to optimize your model to understand a little more about your data here, about your training data. But it's not a fact if I put 100 epochs here, you're gonna have a good model, because we can use and can deliver for your model some bias. As I said before, when you use a data set with not balance, you're gonna create a bias for one answer. Here is the same way. If I do a lot of epochs without using some techniques to understand how we can stop to learning here, how you can stop the path of learning, you're gonna deliver for your model some bias or some things it's not be right for your model, right? So the 3 epochs is a good number here for you to do the tech. If you're gonna use the production, made a study on top of that, understand how you're gonna be your good number of epochs for you use in your model, right? So for us, we're gonna use just 3. So the first thing you're gonna use here inside the model train will be the model train. Gonna use the train model here, and we're gonna deliver for each epoch inside my range of epochs. I gonna print here what epoch we're gonna working for us right now. So we're gonna show for you guys epoch plus 1 because our array is starting 0, and the number of epochs we have here, right? So yeah, this is right. Also, we're gonna create a new variable called total loss. You build the for each app, you're gonna lose some validation of your prediction. Gonna lose some prediction here, so it's good do a measurable with how we're gonna be this loss. More near from the 0, it's better, right? So the total loss, we're gonna receive 0 because we're gonna create another looping here for batch inside your data loader, or for any input of code, for any tokenizer that we do before here. You're gonna receive the input IDs inside the batch, also the attention mask inside your batch, and last but not least, the labels inside your batch here. So right now will be the pipelining of your model training here. The first, you're gonna restart your gradient descending to not stay with the calculations that you do before, to do a new calculation for each batch here. So we're gonna use the optimizer 0 grad. Right now, you're gonna pass the tokenizer that we do before here inside a variable called output. So I will do this prediction with model. You're gonna receive the input IDs, the attention mask, and the labels. Right now, you're gonna create a variable called loss to get the loss about these outputs, right? So the loss will be help us because in that line, the output line here, we're gonna deliver your data for the model, do this prediction, and understand the new data and how it can improve here. So you're gonna improve your data, recover or get the lost data about the inputs from this prediction. Right, so you're gonna pass the output dot loss, and you're gonna use the backward. The backward will be responsible to do what we always speak on the deep learning training, and also right now using the GPT2 to do this training is the back propagation. So you're gonna return and all the maths and all the parameters here, you understand with the loss that we have here in this prediction, and help your model to understand better how we can do this prediction with the new text that we do here. So this is the pipeline, right? And last but not least, we're gonna save on optimizer what my model learned about all these steps, right? So this optimizer step, you're gonna refresh here your model with the new parameters after the learn with the back propagation. So remember the variable called total loss. you're gonna be using here with plus equal loss item to get the alone loss from each item that we have here. You're gonna print here. So loss will be also the loss item. And outside my for here, I can do the average about my loss. That will be the total loss divided by the number of tokenizer that we use in this epoch. So will be the data loader. So we're gonna use the print again to understand. Let me make the F here to do the dynamic variables inside. Average loss for epoch. For you guys understand how we get this optimizer of your model. So more near of the 0, it's better. More near of the 100, it's bad for your model. So we have to see that. So inside your epoch plus 1, because the array starts at 0, will be the average loss. So I guess in the code is this a problem because the indentation here. So let me get straight here. I guess we already have what we have needed here. So let's understand if your model is gonna write. So outside my function, I'm gonna pass train model fact loader optimizer, right? So yes, this train the app because it'll be a default value here. And let's train if let's understand if I have everything right that was needed here. Let's say this. So the first error here is the type error on line 7. Yes. So I don't have the input IDs here inside my batch. Fake loader, input IDs. Here, your data set stay with S. So let me get the right here. So outside my function process fake data, I remove the S from input here and rerun again. I will rerun the optimizer and do the train model here. So another error here. I found 2 errors here in my code. So the first one, the return here, it's not, it's inside the for, so it's just do the first process of training here and return your data. So this data is incomplete here. And another error, it's not an error, but just a little mistake that I'm not to print the item here. So after do that in the code, execute again. So execute the process fake data, the optimizer, and the train. Okay, so right now sounds right. So this is for each epoch. You're gonna use the bring for any token here and do this optimization. So this is the loss. It's near from the 0, so it's a good trainer that we have here. And you're gonna pass all this data for the epoch. And the model that we train here is gonna be responsible to do this optimizer and save your registers here. So this is something really good. So let me pause the video here and I will return and all this training will be ending. Hey guys, Rodolfo from the future. Maybe I'm a little bit different in the video because when I finish the editing of the video, I forgot to explain something very important for you guys. So after this model is It takes some 2 minutes or 3 minutes to train your model. It's very fast because the GPU. But I forgot to explain for you guys how we go export this model for use. For example, if you have to download and use it locally or in another server, you can do that with the model. Save, pre-train it, and you will pass the folder here, the principal folder that we will use here, GPT2 underscore fine tune it. Okay, and also the tokenizer is something new that we create too. So tokenizer, let me change the L for a V here. So tokenizer, save, pre-train it again. And also, like we do if the model is already done for you, as in the HuggingFaces, you will do that. In the same folder, you have the model and the tokenizer, right? So, I forgot here. Just a couple of steps very important for be possible to use this model that we create here. Let execute the cell. Also, I will refresh that, and we already have the GPT-2 fine-tuned folder with our personalized model for the downloader and do whatever we want with this model. We do the personalize on top of the GPT-2. Okay, so right now let's test your model here. So we're gonna receive the model from GPT-2 LM head model from train it. You're gonna receive the same folder here. Also the tokenizer, you're gonna receive GPT-2 tokenizer from pre-train it. Let me update the patch token here with tokenizer EOS token. Let's get this model to device, choose CUDA, and let's see if everything's go right here with some validations of your model. So here I forgot, I put let me get the tokenizer here. Okay, so right now we just load the model from your folder here, and now let's create a function called generate answer. You're gonna receive the question, the max length. Right now you're gonna define the max length for the return from your LL model. You're gonna be 1024, and you're gonna pass the number of bins, so the number of calculations and the probabilistic background of your LL model here. With more non-bins, we have a better answer for your users, but we can understand that the number of bins that we use, that you're gonna make some change for your cost. So we have to think about your resource inside your device, right? So I will put like 5 here, and we're gonna receive the input text with a question, with the question, break the line, and pass the answer, right? Will be my import text. In the input IDs, we need to encode these texts because your model do not understand the just a string, right? We have to tokenizer that. So we're gonna use tokenizer, encode, input text, return tensors as a PyTorch, and last we're gonna bring that to device. Okay, so right now I just needed to generate an answer. I don't need to do a great calculation math, so let me laminate the code here. I will tell that for my code. So I will tell that for my code with torch no grad. So I deliver for my code that I not need do the gradient descending here. So no grad plus a function, and inside of no grad I'm gonna create a variable called output. I'm gonna receive the module generate. Inside the model generate, I'm gonna pass your tokens here, the input IDs, the max length, also the number of beans, we're gonna make some custom here for your code, not repeat the same word in a period of the 2 words that you bring for us. So to do that, you do not repeat any gram size 2. Let's correct that. So size 2. Okay, so we're gonna use also the early stop as true, because my model not need to bring a answer bigger than 1024 here. So I just can use the early stop. It does not need it like we do here with gradient descendant, not need to do a lot of calculation that, so we can stop using that. Unless you can set the token, the pet token ID that we use here, we're gonna deliver that from tokenizer, pet token ID. Okay, so here it's a equal. Outside my model here, I will return with the answer, with the tokenizer. I need encoding to my model understand this will be a token. Now I need the coding to return a string for my code here. So I'm gonna get the first return of this array, and you're not using the special characters here in this return, so I can use the skip special tokens will be true. So here find another error. Let me correct that. Tokenizer here also don't have the input here. Tokenizer to device. Here's tensors. Yes, I guess a couple of this correctly. That was a part of response here that I made a test before, because my GPU, the machine of the GPU, it's turned off, so I have to do the test here. And right now I execute again as a function, so that was because we're not seeing anymore the answer here, but you're gonna find that. Right, so let me verify this answer. So if the answer it contains inside my answer, I will return answer split by the answer -1 to get the last array that, with not a space on the right and the left. Okay. Else I will return the answer with just the strip. So this is a string manipulation here to verify if this inside this decode is bringing to us the answer, right? So let me save this function here, and we can test this function with a question. Will be what it is data science. Let's get the answer from generate answer. We're gonna receive the question, and I will print f question with answer with question, and also answer with answer. All right, let's test here. Let's test. So this don't have no repeat any gram, so I forgot the A here. And there we go. Let me correct the answer here. So what it is data science? It's a field that combines statistics, programming, and domain knowledge to extract insights from data. So another question. How can I get in touch? Okay, so how can I get in touch? You can contact us via email or through email at contact@rodolfomoreira.com. Okay, so that's something very important. This is your first LLM model here, pre-trained with your personalized data. So let me summary here what we do here. So we bring for us some personal data for a FAQ. This is a platform as a couple of courses of data universe as a data science, data engineer, data analyst. So we have a frequently asked questions with some questions and answer here. This is a data set that we use. It's a simple JSON, right? So our goal here, or my goal, is using the GPT-2, the power of the GPT-2 from answer for us open question that will not be ready before, as what is data science, what a data engineer, what the salary of the data engineer is good enough, something like that. So opening questions, and for example, with some exercises, it's gonna be help us for do that. But for some personalized questions, how, for example, how I can get in touch, do you guys offer some certificates, the course will be in person or online. This is something that some questions more directly for the business, right? So right now we can use the power of the GPT through the HuggingFaces here. We use the GPT-2 with the transforms library to help us to get another pre-trained model here using personalized data. So we do the data manipulation, we create a function to do this training, use some techniques of the deep learning, ADAN, age optimization. After that, you can be able to test your model here. So This is something very important, guys. So if you're watching this video until the end, I'd like to say thank you for your time. If you like my video, please subscribe here. Give some feedback about the video if you can understand very well what's going on. If you have some doubts here, be ready to answer that. So get in touch with me. I will love that. I hope that you enjoy. Subscribe to my channel. Leave the like here. So this is it. Thank you, guys. See you next video. Bye bye.